Hello everyone, thank you very much for this opportunity. My name is Mojtaba Esfandiari. So in this video I want to talk about LREProxy engine. LREProxy engine has developed for Kamailio for doing RTP relaying session in voice over IP network. Just some quiet question that would be asked to me. For example, what is LREProxy? What is the main purpose of designing this module? Why I decided to make this module for Kamailio? What challenges led to the design of this module? LREProxy is a kernel RTP engine for relaying RTP packet crossing an IC in your network. The LREProxy architecture is composed of two different layers. The first layer is developed as a module for Kamailio in user space application, and the second layer is developed in Kernel Space as a main decision point for RTP admission controller and a quick path selector. Some challenges might face with you during designing large network. These challenges are topology of your network that you are working on it, security of your network, high availability. What is your solution for having high availability in your network? What about redundancy in your network? And the last thing is, what about the resource? How much resources do you need for each node in your network? Actually, for each node, you have to take more effort to handle it. It could be one of the important challenges. There are some solutions for previous challenges. For example, for redundancy in signaling layer or transport layer, we could use two different methods, active-active or active-passive or active slave. Some solution is related to NFV techniques. Some solution related to high availability in terms of reliable service, and some solution is related to failover services, and some solution related to resources, maybe use OpenStack or AWS or some other etc. solution. The purpose of design. Before I talk about the purpose of design, I should say two important factors that increase the consumption of resource in the network. Call per second. With increasing call per second in network, the consumption of resource would be increased. And the second one, RTP relaying session or RTP relaying crossing an IC. Media relaying crossing an IC in a network increase the consumption of resource in your network. It is the main purpose of design LREProxy. Consumption of resources. Yeah, here it is a system of model that I want to talk about. In the left side, you could see the customer that could your services. In the right picture, you could see your application service. In the bottom of picture, you have your interconnection with other network, with your network. These nodes, SPC back-to-back user agent, are ingress and egress nodes in your network. We want to talk about this node in more detail. Yeah, you could see SPC back-to-back user agent in more detail. For example, we use one Kamailio and one node for LREProxy for relaying RTP, and Kamailio for signaling in our system of model. Architecture of LREProxy. In this picture, you could see LREProxy engine that is registered in a Linux kernel. After a RTP packet received by LREProxy, based on its property, the index destination is calculated, so it could get access to STP information on other endpoint in session. So the packet will be prepaid for forwarding without taking more CPU for forwarding. For other packets, follow normal routing. Take CPU and go up from network stack until reach to application layer. There are three ways for forwarding, control, and data plan traffic. In the first picture, the forwarding is doing by CPU, and the second, the forwarding do by a specific NIC driver, and the second and the third is as do in LREProxy in the kernel space. LREProxy in detail. The first layer is developed as a module for Kamailio. Get all information about creating new session, active sessions, or teardown session, which is gotten from STP body during signaling plan, and relay them to LRE transport stateful that is registered as a module in kernel. The second layer is developed in kernel space, is a main decision point for RTP admission controller and quick path selector to where a receive a packet should be forwarded. For example, the packet should be forwarded to other network, or in the red arrow, the packet should be forwarded to other customer. LREProxy and redundancy. The LREProxy control layer and LREProxy stateful layer could be run as independent function on different machine. For example, we could have one LREProxy control layer with multiple RTP proxy engine and different machine. LREProxy control layer could be work with all of them with different strategy. For example, active or active slave with different strategy like round robin, like linear, and some other etc. It is possible to do not lose session when LREProxy engine crashes. It is one of advantage of using LREProxy. It is actually under development. For example, when LREProxy crashes, all activated session could be moved to another LREProxy engine without tear down the current call. LREProxy and IMS transit media. LREProxy could work as an ingress node in IMS transport layer for transit media. For example, all transit media from a network could transfer by LREProxy to other network with LREProxy. We could integrate LREProxy with RTP Engine, with RTP Proxy or XEMS. It is very straightforward. For example, you could see here the LREProxy could transfer media to RTP Proxy or RTP Engine or XEMS, and one of them could transfer their media to other specific active user agent. We have another Kamailio and LREProxy here. The LREProxy could get all packets from those nodes and transfer them to another node. LREProxy, pros and cons. For example, changing HTTP parameter is done by Kamailio. Actually, I means LREProxy Kamailio, module for Kamailio, not by LREProxy engine. It leads to all child process and threads in Kamailio. It can do changing HTTP parameter itself. Forwarding packet with LREProxy in pre-routing hooking. LREProxy can support NAT traversal for endpoint. Already LREProxy just support audio. The video is under development. LREProxy can transfer RTCP controller between endpoints. Forwarding packets in kernel, you have to enable this option in this config. Unfortunately, LREProxy does not support transcoding right now. Actually, you could make answer for a specific target RTP for lawful interception concern. This option is under development right now. Here you could see LREProxy server with 8 cores and approximately 19 gigabyte of RAM. In high peak, 20,000 concurrent relaying RTP session. We could use in last core just 2 red line. The red line indicate the processing is doing in kernel. Just 2 red line is using for relaying 20,000 concurrent relaying RTP session. Yes, it is really. Actually, you could go to IEEE website for more information about technical academic information about LREProxy with this title: Improve Performance of RTP Relaying Session in IMS Transport Layer with LREProxy. Thank you very much for this opportunity. If you have any question, I'm ready to answer them.